Hello and welcome to Lesson 7 of Computer Systems for National 5 Computing Science. Last week we finished off this first topic, the data representation one. Today we're going to look at computer structure. We'll start off with just the processor, and in the next one we'll look at memory and buses. Here's a presentation to help us. Here's what we're learning. Inside a computer there are four main components. Every computer will have at least these. I mean, obviously you can have lots more components. You'll know lots of different parts in a computer system, but these are the four main ones. We've got CPU, which is also known as the central processing unit. We've got main memory, which comes in two types. We've got RAM and ROM, random access memory and read-only memory. And then you've got back-end storage. And again, there are other parts that are necessary for you to use the computer, but CPU, RAM, ROM, and back-end storage are the four main components. Here's a conceptual diagram of a computer. Obviously, it's not very accurate, but this is conceptually how a computer system works, how all these parts work together. So the input, this is like your keyboard, your mouse, things that send data into the computer. The CPU will detect these inputs, and it will decide what to do with it. Most of it will end up in RAM, which is random access memory. This is a temporary store of the programs that are running on your computer system. It can come back and forth between the CPU, and some things that get permanently saved will be saved in back-end storage, things like your hard drive or your solid-state drive. That's back-end storage, permanent storage, until you delete it, of course. RAM is temporary because when you switch off your computer, all your programs disappear and it's gone. It's wiped, temporary. And output devices, that is things like your monitor, your speakers. This is how you sense the data that's in the computer system. You either see it on screen or you can hear the music being played. That's the output devices. But let's take a look at the CPU, the central processing unit. It's responsible for everything really. Specifically though, calculations, decisions. It's in charge of the whole computer system. It's like the boss, but you'll see later on that there's a part within it that is more like the boss. So that's the CPU. An integral part of the computer system. The CPU has three main parts that you need to know of. The first is the control unit, then you've got the arithmetic logic unit, also known as ALU, and you've got registers. I mentioned the boss of the computer. This is the true boss, the control unit. It monitors and directs and it senses signals from all the other parts of the computer, including the other parts of the CPU. It truly is the boss. It tells the computer how to respond to different signals and to what's happening around the system. It controls all the timings of things that are happening around the computer. That's the control unit. It's in charge. The ALU does all the arithmetic. So arithmetic is maths, calculations. Any numbers that need to be added, they'll be added through the ALU. Comparisons also go through this unit. So that's the logic part of it. Whenever you've written a program and it said something like, if user age is greater than something, then do one of these options, that's logic. It's using logic to choose which course of action to take. That's what the ALU does. And finally, you've got registers. There are many registers, but you don't need to know about the individual registers. You just need to know that there are these things called registers that are tiny memory locations that are physically part of the CPU, and it stores small amounts of data, tiny amounts of data. But because it's physically part of the CPU can access these pieces of data incredibly quickly. It is the fastest type of memory in a computer system, but it's tiny, so you can't just store everything in the registers. That's why we have things like cache, RAM, and backend storage. But any data that is being used right there and then, it will be in the register. So if you're adding two numbers, those two numbers are in the registers while the ALU adds them together. That's a basic example of how these three parts work. Now you might think, hang on, that's a little bit brief. There's not a lot of information in this presentation. Well, take a look at some past paper questions. What do you really need to know? This is from the 2022 question paper, the most recent as of the time of recording. State the part of the processor that will perform the calculation once the program is implemented. So there is some context that I've missed out here, but do you really need it? Which part of the processor performs calculations? It's the ALU, the arithmetic logic unit. Which part of the processor temporarily stores data? That's the registers. Let's take a look at another question paper. 2019. Which part of the processor evaluates conditions? Again, the arithmetic logic unit. And finally, let's take a look at the specimen question paper. That's what SQP stands for. This was in 2018 they made this. When a program's running, it carries out the following tasks. It stores a value and it checks if it's greater than 10. State the part of the processor that would temporarily store the value. Have a think about that one. And state the part of the processor that would compare the sales value to the value 10. You have a think about that, and we'll recap in the next lesson. And that's all we're covering in this video. We will take a look at a bit more in the next one. I'll see you there.